Hello everyone. In this section, we're going to work on 8.6, which is about the inverse and determinant of a matrix. As the first question, this is a 2 by 2 matrix. In order to find the inverse of this matrix, as we have seen before, we're going to um, do 1 over the determinant of this matrix, which is 5 times 6 minus 9 times 0, multiplied by a same size matrix that you would change the position of A sub 1, 1, which is this one, and A sub 2, 2. It means that you would write 6 and 5 here. And for other ones, you would write the opposite. So we know that the opposite is 0, and the opposite of 9 is negative 9. So we're going to have 1 over this one here is 30 minus 0, which is 30, multiplied by this matrix altogether. After simplification, we would have 1 over 5 because 130 times 6 will be 6 over 30. We can divide both by 6, sorry. So you would have 1 over 5. 0 here, and then negative 3 over 10 here, and 1 over 6, this one. Same process for part B, but the difference between part B and A is that for A we have numbers, for B we have letters, variables, and it doesn't matter. So A inverse will be 1 over x squared times x minus 2x times x cubed multiplied by a matrix that you would change the position of x and x squared as you see here, and you would write the opposite of 2x and x cubed here. So A inverse will be 1 over x cubed minus 2x to the fourth, x negative 2x negative x cubed and x squared here. For the first part, in order to be easier, we can factor out x cubed here, and if we factor out x cubed here, we would have 2, excuse me, 1 minus 2x here. So for the answer, we're going to have x over x cubed times 1 minus 2x, negative 2x over x cubed times 1, 2x, negative x cubed over 1 minus 2x, multiplied by x cubed, and the last one, x squared over x cubed times 1, negative 2x. So we can simplify this, and the answer will be, let me write the answer here. If you simplify, you would have 1 over x squared times 1 minus 2x, and you would have negative 2 over x squared times 1 minus 2x. Also, we would have negative 1 over 1 minus 2x here. And the last one, 1 over x times 1 minus 2x here. Next question is number 8. It says, use the determinant to decide whether each matrix is singular or non-singular. For finding if this is singular or not, it means that if the matrix is singular, the determinant of that matrix would be 0, and for non-singular, the determinant of that matrix is not 0. So we know how to find the determinant. In here, determinant of A would be 3 times 4 minus 2 times 6, which will be 12 minus 12, and it's going to be 0. So this is singular. For part B, we can copy the first column and the second column. And you would do this, multiplying these together. So for determinant of A, we're going to have a part of it minus another part of it. For the first part, we're going to have 1 times 2 times 1, which is 1. Oh, sorry, which is 2, plus 0 times whatever it is, 0, and 4, 5, and 2, which makes 40. We will subtract another ones, these, and these. We would have 5 times 2 times 3, which is 30, plus 1 times 6 times 2, which is 12, and the last one, 0, 4, 1, which will be 0. So determinant of A is going to be 42 minus 42. So this one is also singular. But let's say the first one, instead of 4, we had negative 4. So you would have negative 12 minus 12, and the answer would be negative 24. And in this case, it would be non-singular. Number 9. It says for which value of A the matrix is singular. So we know that in order to have a singular matrix, the determinant would be 0. So following the method that we use, we would write the columns here, and we're going to find the determinant of A. So for the first part, we're going to multiply 1, 2, and A squared. So it will be 2A squared plus 1A and 1, which will be A, and 1, 1, 4, which will be 4, minus 1 times 2 times 1 will be 2, plus 1 times A times 4, which will be 4A, and the last one, 1 times A squared here. So we simplify this. We're going to have 2A squared plus A plus 4 minus 2 minus 4A minus A squared. Altogether, determinant of A would be A squared minus 3A plus 2 equals 0. We know that we can factor this out, and we would have A minus 1 times A minus 2, which will be 0. We're going to find two numbers. When we multiply them together, we get 2, and when we add them up, we get negative 3. So either the first one is 0 or the second one is 0. It means that if A is 0 or if A is 2, the matrix would be singular. Number 10, write the system of equation in the form of Ax equals B by identifying the matrix A and the vectors. Okay. So we're going to write the matrix of coefficients times the matrix of variable equals the matrix of constants. So this one will be A, this one will be X, and this one will be B. So we would start the easiest part, which is 0, 5, 1 here. And we know that we have three variables, x sub 1, x sub 2, and x sub 3. So we would follow this order. So this coefficient that you don't see here is 1. The matrix of coefficients for the first row will be 1, 1, 9. The second row, 2, negative 2, and 9. And the third row, we see x sub 1 with no coefficient. It means that is 1. We see x sub 3 with a coefficient 9, but we don't see any x sub 2. It means that the coefficient is 0. Okay, next one, number 11. It says, for which values of k does the system of linear equations have 0, 1, or an infinite number of solutions? So let's see how we can write them in forms of matrices. As we have seen before, this will be the matrix of constants, this will be the matrix of variables, and this one will be the matrix of coefficients. Let's find determinant of A. That would be 3 times 2 minus 1 times k. It means 6 minus k. So if this is 0, it means that k is 6. So when k is 6, the second equation, let me write 6 here. The second equation is a multiple of 2 of the first equation. So if you multiply the first one by 2, you would get the second one. It means that there are infinite number of solutions when k is equal to 6. Because in that case, we have one line here, and we have another line which is parallel to this one. So, not parallel, that would be the same, because if you simplify, you get the same slope. Let's do it another way. You don't have to do it this way, but I want to write it here. So let's try to solve it with the help of substitution. We can find from the first one, we can find x sub 2 as 2 minus 3x sub 1. Let's say we have 6 here. So we would substitute that in the second one. That would be 6x sub 1 plus 2 times, instead of x sub 2, we would write 2 minus 3x sub 1 equals 4. 6x sub 1 plus 4 minus 6x sub 1 is equal to 4. So the left side is going to be 4 and the right side is going to be 4 as well. So this is a correct equation. It means that you have many solutions, infinite number of solutions when k is 6. But sometimes determinant of A, which is 6 minus k, is not 0. In that case, we only have one solution. There is a unique solution. So k can be any number but not 6. Let's say we have 3x sub 1 plus x sub 2 equals 2. And for the second one, we have like x sub 1 plus 2x sub 2 equals 4. Any number but not 6. So I picked 1. Now I'm going to solve this as an example. From the first one, I can write as x sub 2 equals 2 minus 3x sub 1. and I would put it for the next one. So x of 1 plus 2 times, instead of x of 2, I would write 2 minus 3x of 1, which is going to be 4. So we would simplify this as this. We know that 4 and 4 will be cancelled. Left side will be negative 5x of 1, and right side is 0. So x of 1 is going to be 0. And if x of 1 is 0, I would plug that here, and I would have x of 2 as 2. This is the unique solution if k was 1. So you would have solutions for other possible amounts of k, but not 6. Okay, next one, number 12. Find all solutions to the system of linear equations. Of course, if you would use matrices. So if it is better if I write use matrices here. Okay, let's write it in form of 3 different matrices. The matrix of constants, the matrix of variables, and the matrix of coefficients. In order to have a solution, we would find the determinant. That would be 1, because this is A, this is X, and this is B. So determinant of A is 1 multiplied by 5 minus 2 multiplied by 2, which will be 5 minus 4, which is 1, and it is not 0. It means that the matrix is not singular, so we have a solution for that, or we have inverse for that. So in order to solve this equation, if you remember, we had to find A's inverse times B. Since determinant of A is not 0, we can find A inverse. According to the formula, that would be 1 over determinant, which is 1 here, and you would change the position of 5 and 1, and you would write the opposite of others. It means that the inverse would be this matrix. And we are going to multiply this by the matrix of constants, which is 0 and 1. So you would have the answer of multiplying the first row and the column. It means negative 2. And the second row and the column, it means 1. So as a solution, x of 1 is 2 and x of 2 is 1. Number 13. Okay, pause the video, read the question, and then listen to the answer. Okay, so according to the definition that we had in the lecture, and also we brought that here, an equilibrium is the value of the vector for which no changes occurs. It means that instead of y sub t plus 1, we can write only y hat, and also instead of y sub t, because y hat is that value. So we're going to solve this equation. In order to solve this equation, we can factor out y hat. Or before that, maybe it's better if we subtract y hat or the right side from both sides. So we're going to have y hat minus 0.950, 0.051 times y hat equals 0. We're going to factor out the y hat. It will be 1 minus 0.950, 0.051 equals 0. So there is a thing here. It means that inside the parentheses, you are subtracting a matrix from a number, and this is not correct. So in order to cover this, we're going to write the one of the word of matrices, which is the identity matrix. Okay, so I would replace 1 with the matrix, which is of the same size of the other matrix that we have. Now it is correct. We can subtract two different matrices. So we know that y hat cannot be 0. The only thing that can be 0 is this difference. So what is inside the parentheses? That would be when you subtract these two matrices. And the answer for that is 0.05 because 1 minus 0.95 for the first entry is 0.05. For the second one, 0 minus 0 is just 0. And for the entry, which is number 2, 1, will be 0 minus 0.05, which is negative 0.05. And last one, 1 minus 1, which is 0. So this one can be 0, but the determinant of this should be 0 because we cannot change the numbers. How can this determinant be 0? If you find the determinant, you would see that it will be 0.05 times 0 minus 0.05 times 0. So it will be 0 plus 0, which is 0. So therefore, this homogeneous system, because when we have 0, we call it homogeneous system, has infinitely many non-trivial solutions which must satisfy the equation. And the equilibrium that we have would be 0 and a number like k, where k is a real number.